Hello and welcome to vSAN node management. In this chapter, we're going to spend a few minutes talking about your ESXi server. We mentioned earlier that in order to build a vSAN cluster, you need to have X number of ESXi servers. We mentioned earlier that we're talking about minimum 3 ESXi hosts and maximum 64. But it's not just the number of ESXi servers that you're going to use. It's what kind of ESXi server you're going to use. So in this chapter, we're going to talk about certain do's and don'ts and certain best practices. So let's take a look at this next page. When you look at this page, in this particular page, they try to tell you that since vSAN can run extremely I/O intensive workloads, it is once again critical that your hardware is supported. One of the things that I constantly emphasize in class is that you want to make sure that every piece of hardware is supported. You want to take a look at the hardware compatibility list. But if you look at the rest of the statement, here it says performance characteristics and hardware stability cannot be guaranteed if you do not thoroughly test devices, firmware, and driver combinations. So it's not just about the hardware. As you can see here, we're also talking about drivers and we're also talking about firmware. Now, if we go to the next page, here we have the goals for this chapter. Now, when you take a look, we're going to start by spending a couple of minutes talking about the criticality of selecting the appropriate hardware. Once again, making sure that every piece of hardware is supported. If you take a look, we're also going to talk about potential changes that you may want to actually do at the BIOS to ensure that you get optimum performance. Then, we're going to talk about the importance of driver and firmware compatibility. And then lastly, we'll talk about how nowadays you could use Lifecycle Manager to update firmware if needed. Now, when we look at this page, in this page, we can see that we start this topic. And again, here, we're talking about verifying hardware compatibility. In this page at the very bottom, you can see that we show you a URL. And if you never visited that URL, I highly recommend that before you build your cluster, or potentially even if you already have a cluster in place, that you visit that site. In that site, for example, you can see what kind of servers we support. And we're talking about servers from different vendors, not just from one vendor. Some of our customers use, for example, Dell servers. Others will use Supermicro, HP, and so on. Now, when you take a look, one of the most important things is that you take a look at every single component. Now, in the old days in particular, people would try to build vSAN clusters without necessarily looking at the hardware compatibility list. And the biggest problem in the old days is that when you did that, perhaps everything would work fine until you had a problem. And then if you had a problem, then that's when you would notice that, for example, you picked the wrong controller, because then your controller perhaps could become your bottleneck. Now, when we look at the next page, as we talk about controllers, I always emphasize to my students that if you can, number one, you want to have servers with multiple controllers. Now, let's think about this. Let's say that we have a 3-node cluster and we use 3 servers and each server has one controller, one HBA. Now, the idea is if you build a vSAN data store with 3 hosts, assuming that all the hosts have the same number of disks and the disks have the same capacity, if you lose one controller, right off the bat, you lost 1/3 of your capacity. Now, if you had 2 controllers per host, if you were to lose one controller, assuming that you have the same number of drives behind each controller, then instead of losing 33% of your capacity, you would be losing half of that. So more controllers ideally is better than one controller. But besides that, as we talk about controllers, 2 things you want to consider. Number 1, what is the queue depth of your controller? And number 2, did you configure your controller properly? In this page, you can see that when it comes to controllers, depending on which controller you select, you have 2 choices when it comes to configuring the controller. you want to make sure that our software sees every individual disk. So, depending on the controller that you select, either A, you need to set up the controller in pass-through mode, or B, in RAID 0 mode. But what you want to remember is that with our software, we are performing software RAID. So you do not, and let me emphasize this, you do not want to set up hardware RAID and then combine it with software RAID. That would be overkill. Also, that would limit the flexibility that our software has when it comes to choosing where to store the data. So the idea is no matter which controller you have, you want to make sure that once again, we see every single one of the drives. Now, if I go to the next page, here, we're talking about storage controller performance. So we've mentioned that you want to pick the right controller. We've mentioned that you want a controller with a high queue depth. The question is, how can I tell what is the queue depth of my controller? And this is something that you can see with the command line, with one of two commands. Now, if you haven't built your cluster yet, you can see the controller queue depth with ESXtop. I'm going to do a demo at the end of this chapter, and I'm going to show you that. But with ESXtop, you can go to a host, you can type ESXtop, and then you could type D as in disk. Now that will show you all your HBAs. But one of the things you need to remember is that ESXtop does not show every single column. In some cases, you have to add columns. To add a column, you want to press F. And if you press F, then you see additional columns that you could potentially add. Among those columns is the one that you would need in order to be able to see the controller queue depth. And you want to make sure that you have a controller that has a really high queue depth. I would say 1,000 or higher. If you take a look at what we support and don't, I would assume that in the year 2020, I haven't looked at that recently, I would assume that the minimum we support is 512. But I can tell you I've had students that have shown me the output of another command that I'm about to mention. And that command shows, for example, a queue depth of close to 10,000 in some cases. Now, the second command only works if you already built a vSAN cluster. The second command is an ESXCLI vSAN command. If you never use these commands, all you have to do is connect to one of your hosts, type ESXCLI vSAN debug, and in there, you have a namespace called controller. If I type ESXCLI vSAN debug controller list, this will show me every single one of the controllers that I have. Not only that, that command will tell me which one I'm using for vSAN, and it will also show me the controller queue depth. So please remember those two commands. Now, when you take a look, here we make certain suggestions when it comes to how to set up the controller. So make sure that you read every single one of these statements. We've mentioned already that multiple controllers is usually better than one. Once again, you want to think worst case scenario. You want to remember what would happen if I lose a disk or if I lose a controller. So if you have multiple controllers per host, once again, should you lose one of them, the impact on your vSAN data store is going to be less compared to if you have only one controller. Notice, here it tells you at the very bottom of the page, the business wants better performance, which typically requires multiple controllers. So if you think about it, when it comes to best practices, think multiple controllers instead of one, and also multiple disk groups instead of just one disk group per host. Now, when we look at this page, we've mentioned that there's certain things that you could actually modify, both at the BIOS and with the vSphere client, in order to make sure that you get high performance. Now, when you take a look at the very top of this page, you can see in this page, it says the frequency of the physical CPU can be controlled either by the BIOS or by the ESXi host. So which one do you think we recommend? We recommend that this is controlled by your hypervisor. Notice, we tell you that in the middle of a page. In the middle of a page, we say for high performance, consider the following configurations. Number 1, select the OS Control CPU Power Management mode. You can see an illustration on the right side of this page. Number 2, we recommend that you enable Turbo Boost. And if you take a look at this statement here, notice it says, this allows the processor to run faster than the marked frequency in order to increase performance for both single and multi-threaded applications. And lastly, we recommend that you expose BIOS C states to the hypervisor. Now there's a range of C states, and your machine may not have all of them. As you can see in this page, here you can see that the range is between C0 and C6. And just in case if you're not familiar with this, notice here we mentioned that if needed, you could of course make changes at the BIOS and again also with the vSphere client. And again, notice the higher the C number is, the deeper into sleep mode the CPU goes. So here we're talking about making changes, not necessarily to save power, instead to get the best performance that you can. And when you look at this page, as we continue talking about CPU power management, here you can see a change that you could potentially make on the vSphere client. And if you take a look here, we're talking about editing power policy settings. The default is balance, and that is not what we recommend for vSAN. Once again, because you're running extremely I/O intensive workloads, we recommend that you change that to high performance. All right, so that will probably conclude the first part of this chapter, because I want to make sure that you take a break, you stretch your legs. So when we come back, we're going to continue talking about this topic. Thank you.